In our next problem, we have an arithmetic sequence that goes 12, 23, 34, 45 that represents the total number of ounces that a bag weighs after each additional newspaper is added. So if we add newspapers to a bag, that's what this function is going to represent. I want to write a function to represent the sequence. Now it's an arithmetic sequence because we're told that. So let's use our arithmetic sequence. First of all, let's find D. Well, D is 23 minus 12. Or you can go 34 minus 23 or 45 minus 34. And notice you get 11. 23 minus 12 is 11. Now let's write this in function notation using our arithmetic sequence. So I'm going to say T of n equals your first term, which is 12, plus your common difference, which is 11, times n minus 1. There's your answer, arithmetic sequence. Now, let's graph the function and determine the domain. So we're going to start at 12 and we're going to go up to 45. So once again, I think I'm going to count by fives for my y-axis. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. If I have one bag of newspapers, I'm going to have 12 ounces. I should label my axis too. So 1 is going to be at 12. Two is going to be 23. Three bags is going to be 34. And finally, 4 bags is going to be 45. And let's label this. So 1, 2, 3, 4, 5. So these are bags of newspapers. We're measuring bags in newspapers this time. Or number of bags, I should say. And then on the side, this is going to be the weight. We're measuring that in ounces. Now, the domain aren't decimals. They're 1, 2, 3, 4, and so on. We could call those the natural numbers. Either way, you could write it in set notation or you can name it with natural numbers, and that's what we do.